A handful of soil contains thousands and thousands of nematodes. Most of these nematodes are beneficial nematodes. They're involved in nutrient cycling. They're eating bacteria, fungi, and other nematodes. But chances are, if you're in the northern region, you've grown several wheat crops, root-lesion nematodes are going to be in that soil. Okay, so we've got 3 major take-home messages today, and there's going to be repetition, but it'll all sink in. 3 out of 4 paddocks tested in the northern region have root-lesion nematodes. So making the right management decision depends on knowing which nematode species is present, and Steve has emphasised that. But the problem is root-lesion nematodes have a broad range of host crops. Okay, these are the stars of the show. They're usually all females. They're clever little things. The size of these is about 0.6 of a millimetre long. So I'm going to talk about the root-lesion nematodes, Paddocks thornii, and a little bit of Paddocks neglectus. Okay, so they're microscopic. They live in the soil, but they feed and reproduce inside plant roots. Now, they can survive fallow periods, and they're often found deep in the soil profile where they escape the hot, dry conditions of the surface soil, so they can migrate into the soil subsurface. Now, there's a picture here of a nematode egg. There's a little juvenile nematode curled up inside that. And these nematodes can lay up to 40 eggs several times in the season. We've got a really good example of that from our NVT trial last year. So at planting, this is a neglectus site, we had a little bit less than 2,000 neglectus per kilo of soil. 160 days later, we're looking at a 9-fold increase in the number of nematodes at that site. So these nematodes produce a lot of eggs. Okay, last year we spoke at the updates, and a lot of people sent us samples and had their paddocks tested for nematodes. So of the 161 we looked at, the thing to take away from this graph, it's similar to Steve's, is about 3/4 of the samples had root-lesion nematodes present. But Paddocks thornii is the predominant nematode. A positive thing is 17% we didn't detect any nematodes, so there's something good in that. All right, so why should you care about these nematodes? The potential estimated loss in wheat yields is $104 million in the northern region. That's with no management. So that's no crop rotation and no use of tolerant crops. But using these management things, we can bring that down to about 47 million, but it's still a lot. So we're looking at up to 50% yield loss in intolerant wheat, and this is a problem that is Australia-wide. Wherever cereals are grown, you'll find root-lesion nematodes. Okay, if you walk away today with one image, leave with this one. This is the value of a tolerant crop. And Steve has said it, but I'll say it again. Tolerant varieties deliver higher yields. So if you had a thornii site, the tolerant, nice-looking plot here would be something like Gregory or Wiley. An intolerant one, Strzelecki or Petrie. Okay, so the impact in your pocket. This is looking at some high thornii populations at our NVT trial from 2009. Something like Gregory and Wiley yielding about 3.1 tonnes per hectare, Petrie, Strzelecki around 1 tonne per hectare. Okay, so using a 10-year average for wheat and of wheat prices, that's probably a little bit low compared to today. We're looking at a difference of $470 per hectare that you can gain just by choosing a tolerant variety. All right, so testing your farm for nematodes. As Steve said, DEEDI offers a test your farm for nematode service. It costs about $180 per paddock. And PredictorBee offers one as well. So management, there's 3 key issues. We've got protecting uninfected fields, rotating with resistant crops, and choosing tolerant wheat varieties. Okay, and it's worth mentioning just here now that there are no chemicals or nematicides, fumigants registered for use in cereals in the northern grain region. Okay, when we've used these things in fumigants and nematicides in experimental work, we can kill the nematodes in the top layers of the soil, but these nematodes are often found deep in the soil profile. So you're not just getting rid of the nematodes deep in the soil. As soon as you grow a susceptible crop, the nematodes are back and you can't eliminate them. So management relies on just decreasing them to low, manageable levels below this critical level for damage. All right, so let's stop for a take-home message here. So tolerant wheat varieties yield well when root-lesion nematodes are present. I'm sure you know that by now. Tolerance for neglectus, thornii can differ for tolerance to neglectus. So there's information in the wheat variety guides for Queensland, and the new issue should be out, I hope, this week. And there's also information on the NVT website. Okay, we'll just clarify this resistance thing. So tolerance is all about the yield and what's going on above the surface of the soil. Resistance is happening in the soil, in the roots. So if you've got a resistant crop, the nematodes are not reproducing and their numbers are not increasing. There's an example here from some wheat work. It doesn't matter which varieties they are. If you're growing a susceptible crop, you're leaving a big burden of nematodes in the soil for future crops. So resistant crops have a really important role in the long-term management of root lesion nematodes. But a tolerant crop is not always a resistant crop, and I've got quite a few good examples of this in the following slides. All right, so I'm going to talk about some winter crop rotation trial that we've done. It was at a Paddocks thornii site at Four Martin on the Darling Downs in Queensland. Before we started the experiment, you can see the high populations that we have. This is a slice through the soil profile to 150 centimetres. Here's that critical line for damage to intolerant wheat. So down to 90 centimetres, we have very high populations of thornii that are going to damage wheat. So in 2009, we grew wheat, barley, chickpea and faba bean varieties. And we harvested those. There was about a 6-month fallow. And we went back in May last year and collected pre-plant soil samples from every plot. Then in July, we planted the intolerant Strzelecki on top of those plots and EGA Wiley, which is tolerant. Okay, so I'm just going to talk about each crop together. With the wheats, we've got a nice distribution here from intolerant Petrie and Kennedy up to a tolerant Wiley. Now remember where that Wiley is as I go through these slides. These two experimental lines have been chosen by our group because they have some partial resistance to Paddocks thornii. And we have shared this, the material from, that has been developed from these lines with wheat breeders. Okay, so here's a picture of what the plots look like from the lowest yielding to the highest yielding. Something to note here is that in wheat you can see symptoms of root lesion nematode damage, but they're not specific. We've got gaps between the rows, we've got lower leaf yellowing, the plants are wilted, they're upright, the leaves are curled. Okay, so we went in, we harvested those plots, we waited 6 months and went and took soil samples. So these are the results down to 60 centimetres. Now, that orange line is the pre-plant populations. The first thing I want you to take away is that Petrie, Kennedy and Wiley are all susceptible. They're leaving very high populations in the soil compared to the pre-plant populations. But there's some good news here. These experimental lines, which are the future of wheat in this area, are leaving very low populations. It hasn't changed much from the pre-plant populations. Okay, and as I said, in 2010 we went and planted a tolerant or an intolerant wheat on top of all the plots. So here's an example from Kennedy. So huge populations of thornii in the soil in the top 30 centimetres. And you can see the benefit of planting a tolerant crop here. Now unfortunately we had flooding on the day of harvest, so we weren't able to harvest these plots, and these biomass data the biomass data is from October. Right, so a take-home message from the wheat that we had in that trial. A tolerant variety delivers higher yields when root lesion nematodes are present, but a tolerant wheat is not necessarily resistant. Don't get fooled by this. But the good news is that we have 2 experimental lines with greater resistance to thornii than the commercial bred wheats. All right, let's switch to barley. Generally they yielded well, they're quite tolerant, nothing was too outstanding. Just remember where Hindmarsh is here, highest yielding again, Commander's looking pretty good there too. Right, these are what the plots look like, and the thing I want you to take away from this is there are no symptoms of root lesion nematode damage. You can't tell that there are high populations there. You have to get your soil tested for nematodes. When we look in the soil 6 months later after harvest, we've got the orange line again with the pre-plant populations before we started this experiment, and just look at Hindmarsh here at the top. It was the highest yielding barley variety, but it is leaving the highest populations of thornii in the soil. Some good news from this is that Commander is significantly different to the others. It's leaving lower populations compared to the other ones that we've tested. Again, here's this terrible thing. Strzelecki looks terrible. It's intolerant. We've got very high populations following barley Gardner. This is the benefit of planting a tolerant crop like Wiley. Right, so take-home message for barley is that all the varieties tested were susceptible to root lesion nematodes, but they yield well. So don't be tricked. You're not going to see symptoms. You're going to get fairly good yields, but what's going on in the soil is leaving a big burden for future crops. Okay, let's switch to the chickpeas. The ones I want you to notice here are hat trick. We'll just focus on that one today. So it was a nice Okay. Now, a good year for growing chickpeas, and as you can see from the plots, again, we've got no outstanding symptoms of root lesion nematode damage. So don't rely on looking at the crop for a clue. All right, so we've got the orange line showing the pre-plant populations. And the good news here is that hat trick is leaving significantly lower populations compared to the other varieties that we have there. And again, this is a nice contrast actually. This is, although we still have very high populations of thorny eye, which are still at a damaging level for something like Strzelecki, you're still losing yield. This looks like a much better plot compared to when there were very high populations. Those of you who are still awake might notice that this biomass doesn't quite link up with that photo. Some further analysis might explain that. To be continued. All right, so the take-home message for chickpeas. Chickpeas are susceptible to thorny eye. Overall, not as bad as some of the other crops we tested. And the good news is that hat trick was the least susceptible of the chickpea varieties tested and one of the highest yielding. Okay, so the fava beans. The thing to note here, we had to plant these quite late to fit in with the experimental design we have. So the yields aren't amazing, but something to note here is Dozer was one of the highest yielding ones, and keep that in mind for when I show you what's happening in the soil. This AF line is a breeding line. Again, there's no outstanding symptoms of root lesion nematode infection in these plots. Okay, so there's the pre-plant line, and the thing to take away here is the huge populations of thorny eye left after these fava beans. Festiva, Cairo and Dozer are very susceptible, more than just over 20,000 per kilo of soil in the top layers of the soil there. And here's one of those awful slides again. But there's a positive message. There's the benefit of planting a tolerant wheat variety like Wiley. Okay, so the take-home messages for fava bean. All the fava bean varieties tested were very susceptible to thorny eye. Now, Dozer was one of those examples of the most tolerant, but the most susceptible. So we have to finish with something positive about the fava beans. They're resistant to Paddocks neglectus, so they're a great one to include in a rotation where you have neglectus in your fields. So we've got some key messages from the experiment. Now, I've repeated this experiment on another block of land with lower populations, about half the number of thorny eye. The results are still coming in, and it's going to be interesting to compare the results between where we've got this high disease pressure compared to a lower one. But we can still take away some messages from what I've shown you. So all of the winter crops in the experiment were susceptible to Paddocks thorny eye. But a tolerant crop is not necessarily a resistant crop. So we had a good example with the wheat, EGA Wiley, the barley, Hindmarsh, and the fava bean Dozer. And there's another good thing about it, a tolerant wheat variety like Wiley can produce good yields even under very high disease pressure. So it's a very robust way of making sure you've got some income. So what do you do with this information? Test your farm for nematodes, just as Steve said. Choose a tolerant wheat variety and an intolerant one when your results are back, and run your own test strips and just see for yourself the benefits of growing a tolerant wheat variety. Now, unfortunately, the root lesion nematodes do have a broad range of host crops, but there are resistant crops to include in rotations. For example, with thorny eye, wheat, sorghum rotation is good. But come and see us. We've got a booth with more information, and come and see us after the talk. Okay, and just to finish up, I need to thank these two wonderful creatures. John Thompson is still around and he's keeping us all in line and making sure we're putting out some good research. But none of this have been possible without the support of Alex Gwynn. He's a grain grower from the Darling Downs who was the first person to notice there was something going wrong, and he pushed DPI to diagnose this problem about root lesion nematodes. And he continues to support us with the generous use of his land and knowledge. Thank you.
Is there actually any data on the value of farm hygiene? Has there been much research on farm hygiene?
No, not exactly research testing the effect of farm hygiene, and I know it's a difficult thing to do. But these nematodes, for example, move in soil and they move in floodwaters. They're able to survive in water that's moving across land. So if you can do things to control soil erosion and perhaps water movement, you're not bringing nematodes into uninfected fields. Okay, there was a question about the susceptibility, I guess, and tolerance of Jimbor. It's susceptible to Paddocks thorny eye. It's moderately susceptible to neglectus, and Jimbor is tolerant to Paddocks thorny eye and neglectus.